Hi, my name is Troy Scoggins, and I am currently a sophomore at UNC. I'm originally from Cary, North Carolina, and went to Apex High School. An interesting fact about me would be that I'm an avid scuba diver, and my favorite place to scuba dive would be the French Reef in Key Largo. I would like to be a mentor for Professor Austell's analytical chemistry class. The reason I would like to be a mentor is because all the mentors I've had for previous chemistry classes have been very helpful and given me a leg up on the material. I also feel that this will strengthen my background in chemistry as well.
Okay, the problem I am going to be working on is a titration problem that you will commonly see in analytical chemistry. It states that a 50 milliliter solution of 0.14 molar butanoic acid is titrated with 0.100 molar potassium hydroxide, and you must find the volumes and pHs requested below. But first of all, we need to know what the Ka value of butanoic acid is, because this will be used in most all sections of the problem. This can be found by looking at the reference guide, and I have checked the reference guide and determined the Ka of butanoic acid to be 1.52 times 10 to the negative 5. Okay, now looking at this first problem, what volume of base is needed to reach a pH of 7? So this will be a Henderson-Hasselbalch problem. The Henderson-Hasselbalch equation is given as pH equals the pKa of the acid plus the log of the concentration of base over the concentration of acid. Okay, the first thing to do in this problem would be to determine the pKa of butanoic acid. This can be done by taking the negative log of the Ka value of the acid. So that is 1.52 times 10 to the negative 5. This equals 4.818. Now this can start to form the Henderson-Hasselbalch equation. So the pH we are going to reach at the end is 7. So we set the pH on this side to 7. The pKa of butanoic acid is 4.818. Now this equation is starting to come together. So we start and keep going, and we have the log, and now we need to find the moles of acid in the solution to start this section of the equation. So to do this, you will multiply the molarity value by the milliliter value, but convert this to liters first in order to get a correct value. So this will be 0.05 liters. This gives you a mole value of 0.007 moles. The reason to convert this to moles is because it will be much easier to deal with the problem in moles instead of concentrations, since the volume of solution will be ever changing. Okay, so the unknown value in this problem is the volume of base, which can also be an unknown of the moles of base. So that means that in this Henderson-Hasselbalch equation, our x value will be the moles of base. So it will be 7 equals 4.818 plus a log of x, which is the base moles, over 0.007 moles of acid minus x. You must subtract x from this value of acid, because when the acid and base interacts, it will negate itself out. Now that we have this Henderson-Hasselbalch equation set up, all we have to do is solve for the moles of base needed to reach this pH value, which we can convert later to the volume of base. So starting to solve this equation, subtract this value from both sides, giving us 2.182 2 equals log of x over 0.007 minus x. The next step in this problem is to negate this log here by changing it to an exponential equation. So this means putting 10 to this power and 10 to this power. This cancels out this right here and leaves us with 10 to the 2.182 equals x over 0.007 minus x. Now the next step would be to multiply this side. This will give us a value of 1.064 minus 10 to the 2.182 x equals x. Now all that's left to do is solve for x in this case. Now solving for x in this equation, we get that x, which is the moles of base needed to reach the pH value of 7, is 0.00695 moles. Now this can be converted to the volume of base by dividing by the molarity of the original base solution. So divide this value by 0.1 molar, which will give you 0.0695 liters, or 69.5 milliliters.